Is everyone ready? Good afternoon. Good afternoon, ladies and gentlemen. Welcome back. I hope you took the time to visit the exhibition area and see an exhibit or two. I really enjoyed it myself. This afternoon, we're going to start with a panel discussion. It's going to be on the effect of AI on society. After that, we're going to have 3 keynote speakers. Then at 4:30, you're going to see 4 young and talented scientists who are going to make a pitch of their fresh ideas. And then we're going to conclude this afternoon with, in artistic fashion, with an art and science performance. At this time, I'd like to introduce the panel. Véronique Auberger. She is a researcher, and she works at the University of Grenoble. She's a specialist in ethics as it relates to technology. Also with us, Sarjun Scaff, who you met this morning. He's the CTO of Bossa Nova Robotics. Then we have Patrick Gros, you also met this morning. He's a AI software specialist, and he's the director of INRIA. And we're also pleased to welcome Jean-René Lequepes, who is the CTO of CEA-Leti. So to get things started, I'm going to ask Véronique the first question, which is, how do you see AI affecting society? Véronique?
Yeah. So it's a title you gave to me. How AI will affect society, benefit and risk. Wow. You can guess I cannot answer this question, of course. But perhaps what I can point is that perhaps it is the main question that each of us in our professional and social roles, they are numerous, and each of our institutions have to take as a key point now and as an emergency question. And why do I say that? Because if you do not look inside the society and the consequences and impact of AR, but inside the AR makers, researchers and companies who are building the AR, look at this very recent work from MIT and Media Lab. You will see that since 5-10 years, there is an exponential quantity of work about AR. Is it about AR or labeled as AR? You have seen many things about definition. That's not the problem. It's labeled AR. So numerous. And at the same time, there are fewer and fewer and fewer kind of models that are discussed, that are explored to understand what can be the good model to develop the good horizon, to make the better implementation that really are coherent with our natural world and cultural world. And as you see, not only there is a few models, but since 5 years, there is quite only machine learning models. And among these machine learning models, one winner is the deep learning neural networks and the deep neural network models family, which are the best to can take into account the larger sample of data. So we understand very quickly. And if you go on the bottom, you see that the actors of AR are more and more numerous in quantity of people, but less and less numerous in quantity of author, citation, the paper which are famous, and the institution. You know, you have seen a lot of Occidental US institution and now mixed with China institution, but not so numerous, even if people are numerous. When I was 20, 30 years old, we were very few in computer science working on AR, but there were so many models. We wanted to understand and model the nature, and we wanted to make some quickie thing with machine learning, but we had no data. And so, what happened? What happened? Is it new? Is it new for the human to build tools? No, it's not new. From the beginning, it's not only the human, but the human is very good to repair or augment like that the body, my abilities to talk to somebody very far, to go very far and very quick with no effort, and so on, to have a good memory with my smartphone, a lot of memory on Google, on the network. The very young teenager do not need any more the short or long-term memories. They can go to the data center very quickly on the cloud. So that's not new to want to extend myself. And is it inside my body or outside my body? When I drive in my car, it's not my body, but everything is cognitively inscribed at low level, and I can drive without to know I'm driving. So it's a very long story. Is it new? What is new is this feeling that it's not physical, embodied machines. It's digital. It's algorithm. Bypass an algorithm was a machine, the mechanics. Now it's the cloud. It's not physics. Of course it is. But you cannot have the direct feeling it is. So that's perhaps a difference. And the main difference is something which is only an epiphenomena of the reality of the technology, but a main phenomena to attract our attention of everybody in the public about what is AR. That is robots. There is no robots in reality. Just a few, like your Bossa Nova, but in comparison with the bot for making financial processing in the banks, it's so few. But we are obsessed by that. I'm often asked to talk about robots, but I don't know. Have you a robot at home? Not sure you have. I have no robot at home, especially not a social robot. But in fact, it's not new. It's very common in mythology, but in reality, it's not new. 2,000 years before the ancient Egypt, there was the first talking machine. And again, several times during the time, all the time to help the leader to be very dominant with people because God is here talking with a talking machine. That was technology very well described. And you are in Grenoble, you see, it's a duck. It was not called a robot at this moment, only automaton, machine, okay? And it was a fake, in fact, but we don't care. People were very impressed. Nobody has to take the robot to put in the bedroom to get a social robot. So the question is, what happened to us to have a so big desire, not only to talk about this kind of machine, but to perceive this machine as not anymore an object, a thing, but somebody. It's very, very different because when you are somebody else than me, I cannot tinkle myself. You can tickle me and put me on the floor. That's very important for the machine to be somebody else and not an extension of me. Not like that. Very important. And if you have to robot builders, in my lab, we build robots. We cannot say, why this machine, my smartphone is not a robot. Your machine are a robot. Why? You can give some cues. I can give some controversial example. So we don't know. The only thing we know is that we humans decide and we want to perceive that as robots, even if we are not animals at all, even if when a little child have security blankets, we are very careful to tell to them, please do not attach. That is a thing. That's different in Japan. They have animist culture, we have not. But however, we want robots. So the real question we think is to ask why. Why do we want such things? Look, I'll give you an example. It's a very old one, for robots, it's old. 2016, it was Boston Dynamics. At this time, it was owned by Google. Now it's SoftBank. After this problem, coincidence or not, you have to ask them. So it's a crash test. It was built to clean the environment dangerous for human. So that goes to the dangerous environment. There is no human, and it's very resistive. You can put it down. You can boot the thing all the time. This is very resistive. Okay, crash test like for a car. okay? And they are very happy. They put it on the web. There is a very big buzz. First buzz is, oh, you are torturing this poor robot. Very big buzz. So the engineers say, no, 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 we are a very good person. We do that for you. It's not a social robot. It's humanoid because of the use, because it survives. In fact, it's not for a human. It's for to save human. We are good. We save you. And a proof is that we didn't do anything for this. Call it a head. It's not a head. It's a camera to have the environment. But yes, there is no voice, no talk. Second buzz, oh, poor robots. Not only you torture them, but it cannot defend by talking. And it's not so funny because it was a big problem for Google. And the last one, the third, after that, everything disappeared for a time. Now it came again. There was a tweet, a very buzzy tweet, which was that, oh, be careful, they could uprise. Okay? And I don't know if you have seen a buzz last week, which was to make a parody of that, where at the end the robot took a gun to put the human outside. So, again, the aim of this parody was to say to people, oh, it's only machines. But in reality, people reacted by telling, oh, we don't know if it's clever or oh, 2 minutes, okay. So, just to say, robots you have no at home, it's just something we think a lot about, social robots. There is service robot, and it's very difficult to avoid people to interpret all the thing of the robots making the service has social language intention, very difficult. But what happened now in all our home since 2 years, a few years ago we have a lot of chatbots, real human, very human in voice, but nobody except the acoustic, and it was not very used. And since they came back to very, very old technology, which is exactly a loudspeaker, round, put on a table, you have to move on it, you have to do that on the kitchen. Since Alexa, Google Assistant, Cortana and Son, they have built that, they have sold so many. And the use of that is now, a colleague of Orange Lab told me, for example, Alexa is now educating children in a lot of family in US since something like 6 months. They could know that. And at the same time, what did happen to us? We are connecting human to human in exponential number of human in comparison with the face-to-face with only the body than we did before. And when we connect together, even if we can have video or sounds, like, for example, in the Chinese social network, we erase it. So we never interact with so many people without the body, and at the same time, we create an intimacy with a machine, which is absolutely nothing else than a loudspeaker, but a voice, to have the feeling that it is, or she is, or he is somebody. So the real question is, what is the meaning of that to us? So just a very possible beginning of answer is that we can observe in the same time that in every place of the world, in every place of the society, the feeling of exhalation is increasing a lot. The feeling of isolation is not to be alone, it's to feel to be alone. And interaction, perhaps you don't know that, but it is as vital as to have nutrients, or as to have water, or as to have correct temperature outside, is vital. If you are not indirectly, by good interaction, filled, you will die. Slowly but surely you die. Is it what happens to us? In the same time, in accident, we are thinking at what happens to the animal we have integrated in our social space. We are reconsidering things. We are reconsidering everything. Is this focus on robots we are doing here now culturally is an emerging point of a very big movement or not? It's what we think. I think I have no time to show you this video where we can, just with little noises, we can manipulate an isolated person by convincing her effectively that she's well, she's attached to the thing, she's not dominated, she's not dominant, and even the robot can convince her that the robot is frail, and the robot has to be cared by the person and not only the country. I have no time to do that, but I will just finish on that. What I would like to tell to my colleagues for this roundtable is that often we say, what are the benefits and the risk of AR? It's a title. And 2 weeks ago, I was with a very little child, 10 years, with a knife, and she told me the knife is not dangerous. The danger is me or you, depending on what to do with that. So it's so obvious, no? 10 years old. We just need to remember that when we are pointing at AA with our finger, what is pointed is human, not AA. And why do we develop so deeply, so largely, so widely this AA everywhere, in every domain? Why are we, as an epiphenomenon, but so important culturally, obsessed by this machine? It's not nothing. Remember, transhumanism is an idea very, very well developed, and the Singularity University became a Singularity Church a few months ago, held by big companies. So we don't know what is happening, but we need to know that we don't know. Is it something serious? Yes, but it's very normal. Each time we have something new, we don't know how we will be transformed. What would be dangerous would be if we do not have open eyes to do that. And remember the first slide? In the AA makers, no social people, no politician, no associative people. It's only builders.
Thank you, Melanie. Let's give her a round of applause. So, moving from this question of risk and benefits, and one particular element that concerns us all is about data privacy and security. So what can you tell us, gentlemen? How do you feel about the risk of infringements? Sargin.
So perhaps I'll start from a retail-centric environment because that's what I know best. Security is paramount in retail. You may remember a few years ago there was a credit card breach at Target. It was so bad that the CEO lost his job. And since then, retailers who typically aren't technology companies became like some of the best on the security front. So anytime we are deploying something within a retail space, one of the checkboxes is that we are very secure with the data and also building some logical firewalls between our data and then making sure that we cannot cross boundaries in dangerous way. So at least from a security perspective, not talking about privacy, there are industry standards that help guide us in the way we implement systems.
And in terms of who is responsible, do you think governments should be responsible for implementing laws, or is it business that should take control, or is it society at large?
At least on security, it looks like sometimes, to some extent, the government, from a military perspective, blazes the trail and shows what are the concerns that they should worry about. But also business, for practical reasons, like what I described. I think privacy is the one that protects the individual, and I think there is a definite remit for government to play a big role. That's my view.
Any comments, gentlemen?
Yeah, first. Yeah, about privacy, I would say the main risk is coming from people who think they don't care because they have nothing to protect or nothing to hide. Because, of course, if you think about your neighbors or people who don't care about you, of course, they don't care about your data. But who cares about the fact that you go to shopping every Monday afternoon? The guy who wants to steal your house and to visit and to take your car while you are not there, he cares about your data. And who cares about the fact that you go to hospital from time to time? Nobody, but your health insurance can care. And so you are never sure about who will do something with your data someday. And even if you don't have enemies, you have people having not the same interest as you on your life, because they want the information they can get on your health, on your day-to-day habits, and okay, can do something with that, about your credit card number, about your health insurance, about your working habits, and so on. And so it's like with Google, when you give, or Facebook, when you give the data once, it's done for the rest of your life. It's not possible to say, hey, stop everything, give my data back. And so I think the first thing is we should care. We don't know exactly what will be the risk, but we should care.
And we saw this morning that there was a relative discrepancy between the Chinese and American school of thinking and the European school, which is much more protective of data and privacy.
I think that it's not a new problem. In fact, each time we develop a new system, a complex embedded system. You hear me? No?
Yes.
Yeah, a complex system, an embedded complex system, it's, I would say, we need to have some strong requirement in terms of security, of data privacy, in order to have the adequate system, providing the adequate level of security, the adequate level of protection of your data. I think that AI is part of the game today, and it would be the signal processing toolbox of tomorrow for people developing complex systems. So nothing new compared to other systems. So we need to protect our data and to have a high level of security for your own data. If you say that it is, I would say, my own data that I don't want to be in the cloud. And I need to have an adequate level of security. But it's based on some requirement, based on a given application.
So to a certain extent,
To
a degree of individual behavior too.
Individual behavior too, but we need to be aware of the risks that we have when you use such kind of application.
Okay.
Yeah, and again, it's a cultural thing, because it's relative to something which has to do with the law, which is implemented in the law, and the way to regulate the country. For example, in China, it's not shocking for people, or if it is shocking, it's a very long-term cultural and political way to know if it's good or not, that everybody knows that you are a bad man. Okay? And if you do that in US, it's very different. And if you do as in Europe, I discussed with people thinking to the law difference between US and Europe is very different. For example, what can we do if our data, because we don't know they are precious, we give our data, they are now somewhere on a data center in US, regulated by US way to think what is privacy. I am not the same way to think to my privacy that an American guy in San Francisco, because I'm not the same culture. And it must be regulated in the place where we are, but the data and the system are not built at the place where we are.
They can go anywhere. So now let's move. Did you have a comment, Sarjan?
Maybe a controversial question to my fellow panelists. So we heard that China has a different approach to privacy than the Western world. Even within the Western world, there are differences among countries. There is an argument, perhaps, to say that the more permissive societies would allow technology to accelerate its development. For example, if you look at publishing of AI in China, it may have surpassed the US publishing on AI. Mostly because there's so much data, because it's less restrictive for you to capture that data over there. And if I draw parallels to the medical field, when you have a new medical device, where do you test it? Not in the Western world,
yes, that's right?
So there may be an argument for doing like peaks of acceleration and then going back within the protection of privacy.
As discussed this morning, probably AGI will be a nice solution to ensure a better security of our own data, personal data, and to ensure better security. It's why we need to process data as soon as possible instead of avoiding sending them in the cloud and to receive some answer.
So edge AI has
Edge
been
AI has been, I would
a form
say,
of protection.
Yeah, good protection against, I would say, privacy, data privacy, and security.
Okay, now let's move on to the question of behavior. And staying with you, Sarjin, as an industrialist, how do you see behavior being modified by AI and by robots?
Human behavior?
Human behavior.
I think...
Including the way people live and shop,
Yes, absolutely. The way it's shaping up, according to my observation, is the first location where this will change is the workplace. It's where the injection of AI and robotics and automation makes commercial sense. We can motivate them, so they're going there first. And what historically, the speed of disruption has a direct correlation to job loss. But in my perspective, it's such AI and automation is so complex that technology isn't going to allow us to deploy very fast. And so what we will see is introductions of technologies into the workplace that is a helper at first, where technology is being seen and perceived as a tool, an empowering tool that frees up from the mundane and the uninteresting and perhaps the dirty, et cetera, so the humans can be freed up to be more human, essentially. And the behavior of the human towards a machine, I think we don't really know how it will shape up, but it is our responsibility to collaborate, industrialists with academia and others, to really figure out what is the right way for the robots to behave around people and converge on conventions to how people need to interpret robots. And maybe they need to change a little bit of behavior around robots, but I think mostly it will be technology adapting to human. That's the only way for technology to succeed.
Okay.
Could I complete that? I completely agree. We have to observe what are the code changing, but we can say what is happening, but perhaps to decide if it's good or not. It's just a pure global cultural process implying greatly the politics, the law, Supplier, and so on. All the steps of the society must decide if it's good or not. Yeah. The role, I think, of industrial and academic together is to say, this is happening. This is what is happening. This is the effect. But to decide if it's good or bad, I really think it should be better to say nothing and to leave the social complexity system to do what we previously do for medicine, for example. And it's not the case because there is a lot of committees of ethics held by industrial or scientific which say it's good or bad.
If I can comment a little bit, machine has no ethic. It's the people who are using the machine and the people who are using programming and developing application using robots, for example. And those people have been educated, has to be educated in order to have, I would say, good ethics and good practice. So and to use AI in a good way.
We have a question coming in from SMS, which is how can you secure 100% of your data in your daily life?
No, you cannot.
You cannot.
You can choose that you will protect part of your data because you think they are important, but you cannot secure everything. Or you just throw away all your electronic devices and credit cards and you just live with no interaction with other people. But otherwise, just your neighbor saw you going out of your house. This is private information which is just run out. So I think that it's just a question of, okay, proportion, I would say, rather than 100%.
So in other words, you can protect some of your data some of the time, but you can't protect all of your data all of the time. Going on, though, and taking the question to R&D, what could we do upstream in R&D to increase data security? In two words.
Security, in 2 words. Security is an important. Security and safety is an important topic for CEA because CEA is a French atomic energy agency, and we are working on new generation of nuclear plants. We are developing nuclear weapons also, so it's part of our DNA. to ensure a good level of security and safety, either for people and for our building. We have been developing in the past several solutions for that, developing some operating systems, some real-time operating system to manage our security of nuclear plants, for example, in real time. We developed some cryptography solution, providing solution to provide, I would say, calculation on some encrypted data in order to bring a very high level of privacy for your own data. We develop also, we have a CESTI laboratory, which is an evaluation center for information technology, for developing, I would say, evaluation of security, level of security of a product, industrial product, before putting it on the market, and to be sure that the adequate level of security. We have security in our clean room, for example. We try to remove, I would say, lead in our processes in order, for example, to use other materials in order to bring, I would say, more security for people. We need to remove carcinogenic chemistries in our clean room to ensure safety of our people. And for AI, for example, what is today problematic probably is that algorithm, if we are discussing about deep learning, as working as a black box with some input and some output, and we do not know how the results are obtained, and we are not able to explain the result. And so we need to have trust in our AI solutions. And François Terrier here will provide a talk on that topics later on.
In just a minute.
And it will be an amazing topic, I'm pretty sure.
We have another question coming in, which is, do you think AI will be smarter than human intelligence?
Stupid question.
I agree with her.
It's a yes/no question.
Yeah. No.
Okay.
For some cases, yes. For some cases, when we are looking for some optimization problem, I would say AI is the right solution.
And certain calculations.
Yeah.
Okay then. Patrick, anything to add?
As I said this morning, in fact, there is no intelligence in AI. So AI is better for do math, to do data analysis and so on. But this is not intelligence. This is just a way to apply algorithm to data. Okay, it's faster, it's better, it's whatever. But in terms of real intelligence, I think it's a different category.
I think it's the same question that to say, is that more intelligent than my leg? I think it's the same question, in fact.
Only when your
You
leg
can
hurts.
forget algorithm, yeah.
Okay. Continuing down the path of potential risk, do you think that AI could lead to increasing discrimination? Veronique.
What we already remarked, for example, there was an experience made by, I think, Microsoft with a bot which name was Tide 1 year ago, I think. And instead to grow the machine learning was previously decided by themselves, they decided to put it on the web and to let people feed by data the machine learning processing. And is it because people say, I will demonstrate it, that it cannot be a right action like that? Or is it because some people were more motivated? Is it because it is a state of the world? But after one day, a Thai was racist, sexist, terrible. Okay? So now that's quite funny. But now in the government, European governments, many people work on how to regulate a device which would be just filled with small data and given to a family, and for example, your car. And if you are a very, very dangerous driver, will your car become a dangerous driver? Is it your fault, the fault of who? Okay? So what we have remarked for now, for example, I work on speech recognition and synthesis this year, and at the beginning, you could not find the voice of an old person, and of sure not of an old woman. Now, for recognition of faces, it's very difficult to be recognized if you are a woman. Moreover, if you are a black woman, you have no chance to be recognized. Is it because the AI systems are terrible, or is it because the way we have chosen to collect the data, or we can access to the data to give the data, or when the builder have chosen to feed the data is bad or bad? It's a bias of the society itself, and all the fact we can access or not to the internet to give the data. We decide to collect there or not there. We decide to learn or not to learn with such kind of data. So, of course, for example, take the robots. The social robots, when they are humanoid, they are white, they are young, they are very kind, never angry, okay? And always man, except when you are in an Arabic country and you want to make a buzz and you take a woman. And it's not a robot, it's just...
problem of the...
I
think it's mainly...
Men, human, and the state of the society.
Veronique, it's mainly the problem due to the database and the learning phase. We need to be sure that the database and the learning phase
the database
do not introduce that biases.
We chose, somebody had chosen,
yes.
and it was a fact that some people can access.
Yeah, but
and some people cannot access.
We can prevent such kind of risk if there is a large database which is well labeled and representative of what we are looking for.
In this time, AR first reveals a human societal functioning. What is the functioning that AR reveals? So AI is a good observer of us. And after, because AR will act, will continue, what we will do with that?
So continuing on that question, what should governments or even customer care and businesses be doing about this?
The question is, if we give the power to the systems, the bias will be used directly to decisions. If I know, for example, the people who archive TV in France, they have been archiving data for years and years. And they know, the documentalists know that if you are looking something from the 70s, you should ask a question like that and blah, blah, blah. Because at that time, the person were doing things in that way. And if you are looking at a document in the 80s, you're quite... And I think with AI, it will be the same. This is, you will have a system to help you take decisions, but you know that it is biased in this way, and then a human can counterbalance, in fact, this kind of bias because he knows that the system is too cautious on this aspect and is probably take too risk on this other aspect. So you need someone else some kind of global view, an experiment in order to say, okay, this system is good for something and not good for other things. And it's very difficult for a system to do that because it's just a matter of experiment and not only a matter of already labeled data in huge data and so on. So it's very difficult to learn this bias by just looking at the system. So I think these systems are done to help us, not to take our place in terms of decision.
So we spoke about this a little bit this morning, but in terms of certification, is there a way that people can get a certification process started? Is that a regional, a global scale?
I think it's not possible to have a certification scheme for everything, but in some domain, in fact, it's quite easy probably to define some basic tests to verify that there are not too many bias. Because you know, for example, if you have to recognize people that you have usual bias about gender, about color of the skin, about age, about origin from all over parts of the world, about language, about blah, 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 and blah, blah, blah. So, okay, we can have tests about that to verify if it works well or not according to what we want to do. But it's not possible, I think, to have just a certification process for everything because there are so many different applications.
First, I think that we need to provide a more robust solution for AI to provide, I would say, some trust in the result which is obtained and a result which can be explainable by people. Because normally, if you look at the law today, we need to explain the result of an algorithm. And so it's mandatory to legislate, probably in this field, in order to be sure that we have the right answer.
So do you think we need to have some sort of international human rights to govern AI?
It's right that the European Commission has created a high-level group for working on ethics and AI. So it has been launched, I would say, 18 months ago, more or less. And it's, I would say, 52 people, so a small number of people, which are going to make recommendation to the European Commission.
Okay. So coming back to industry, Sarjun, how do you see norms and conventions being put into place, and will they be strong enough to ensure privacy?
So from privacy, I think the answer is yes. The entire world, at least, at the US, we think we're the entire world. At least in the US, we are following the lead of Europe on GDPR for the protection of privacy. I think there is a built-in, in industry at least, there is just a built-in protection, essentially, because if you don't do things right, you are probably not going to succeed commercially, and so you have to be careful about aspects of that nature. And for example, on the, we talk about security. In our case, we had to worry a lot about privacy because we have cameras on our robots, and we have to make sure that if those cameras do capture people, that we have technology in place so that we are able to either remove them from the images or not save the images. And all of these are codified in the GDPR that we follow, even in the US where it doesn't apply. So there are best practices that are being developed around the world. I do think that cultural norms are different by societies, even if technology is really global. But it would be good to follow the lead of those who have thought most about it, and in the privacy case, it's Europe.
Okay. Now, moving on to, you want to add something? This question, which is for edge AI, when do you see AI starting to make decisions, for example, for driving, for medical decisions, for weapons?
For driving, my feeling it's coming already. So there is a huge number of experimentation in the world on other solution. But there is still a key question which is not answered yet. In case of accident, who will be responsible? Would it be the driver? Is it the driver? The driver will do nothing. Is it the chip provider for the ADAS? Is it the software provider? Is it the provider of the database which has been used to learn the system? So you can see that the answer is very difficult, and it's difficult, tough questions. And we need probably to have some new legislation in order to provide the right answer. Even if we know that autonomous vehicles, there will be 10,000 less accidents than today. When there is one accident, what happens? Who is responsible?
That's right.
That's the big question. Patrick.
For medical technologies, okay, we had a discussion with the press, and there was the CEO of Diabloop. Okay, so what he said is just, it's here. What he developed is his medical device to help people with diabetes. It's there, and I think when you have a pacemaker, you will have AI in the pacemaker. If it's not done, it will be done soon, in fact, just to help find, to adapt better the pacemaker to what you are doing in your life and so on and so on. So I think it's there. But it's very limited in terms of what it does, and it's very, it's not some general eyes to do everything.
So it's making decisions within an established protocol.
A very, very specific case for this disease or this case, and try to get help from the data got from other people, obtained from other people, to help in your case to find the good regulation of what you're doing. Okay, how it works for insulin or for pacemaker or for whatever this kind of device. I think it's already there.
And so for such an application, security is very important.
Very important. So I think that for the case of the self-driving car, it is very much work in progress. We're still learning about it, and it's a bit premature to think of going anywhere close to regulation on it. Except around safety boundaries, where actually regulation helps guide development. It's a positive, not a negative. But I hope that societies can come together on red lines, for example, like as far as I'm concerned, for weapons, it should not be up to anything other than saying just no, never. And that's a society's decision that it needs to make.
So really on a case-by-case basis.
Yeah, case-by-case basis.
Moving on, we have a question that was mentioned this morning that hundreds of millions of people could potentially be put out of work or not needed any longer for certain types of jobs. So how should education systems be preparing us for this change?
Yeah.
And Veronique sighs.
Yeah, that's not a new question, but it's a massive, urgent emergency question. But it's not new. The Industrial Revolution happened once, and people have to change. Each time we change. Okay, the question is the rapidity of the change and how we react to that. For example, I work a lot with elderly people, and how to introduce today technologies for people who were not trained to do that. And when they think to their work, to their job just before, they could not imagine to change. For example, the bank companies are many to have implemented a lot of bots to help people. And there is a big crisis in the job of bank people because they don't know how they can retrieve the decision level of the decision level that helps her, and it's exactly the same for you talk about medicine, that's exactly the same for the surgery. In medicine, for example, the radiologues now have not the same job that they have 10 years ago, because many things are automatically traced. And they were ready to react in medicine, they are not ready to react in the bank. Why? Yeah. Right, same level of studies, but not the same cultures. So again, it's a society decision, and we need really to make a very big effort to not to learn people to use the thing, but to understand what is it.
Yeah. I think it's also hard to tell ahead of time. It's predicting the future is just difficult, and sometimes technology opens other opportunities that didn't exist before, which means it's not a zero-sum game, and you may lose some here, you will gain maybe even more there, perhaps even at the same skill level, so education, in this case, wouldn't have to react. Although I completely agree, just looking at the big trends from industrialization and what it did to the agricultural sector, all of this, clearly we're getting a more prosperous society, we have more time for leisure, etc. And so it's all going towards that trend where we can automate more and gain more and more time for ourselves, and that goes hand in hand with education going higher and higher. In our case, for example, just to give an example of not knowing the immediate impact of technology, our robots that are capturing the data actually enable stores to deliver products to the home. Well, the way you do that is you get store employees to go and pick the products for you. So the data created new jobs just in this example. So it's just hard to tell, and we have to keep an open mind, keep investing in education. That's the most important, that's the best insurance policy we have.
But even if it doesn't change your job, it changes your life in your job. I give you another example. I work with a robot which was supposed to purify the air, and it was very, very careful to avoid everything that is human too. And at the bottom of the building, the secretary said that the percentage of perfection is very bad, and moreover, I feel very bad because even the robots doesn't want to come to me. It avoids me. At the hub, the leader, the head of the company say, oh, it's a very good percentage. I will buy it because he is very, very polite with me. And that makes, just for one experience, for 1 year, that have made many changing in the relation of people and the way our people evaluate themselves, even if the robot has not changed their job. And some soldiers just come back 3 months ago from a war in US after a war in Arabic countries, and that was a new use of robot assistant, and they are very strong processing to put away the post-traumatic stress, and they could make good thing for people who has lose a arm, a leg, and even a friend, another soldier, but from the one who was lost the robot, they cannot do anything. A class is the same as the soldier which are for the bomb. They need to make some, I forget the name, enterrement,
A burial.
funerals
Right.
for big. Imagine for the first workers on the loom Jacquard 2 centuries ago, when it shut down, he didn't say, "My God." This morning on the radio, somebody from General Electric said, "My machine is stopped. My machine will go in another country." And he gave a name to the machine, and he was affected by the machine itself. It would not happen a few years ago for the same machine. We are changing.
And having an emotional contact with the machines.
We are affected
We
still
always
now.
do it,
We
yes.
are affected. We don't know how and why, but we are still, even if our job is not yet changing.
So just a word to close. How do you see machines, and you've answered this question partly, how do you see machines affecting human behavior in the future?
Like, it depends on the length of that arc. I think the longer arc is really freeing giving prosperity to to society and freeing them up for more leisure time. It sounds a bit too rosy, and we have to be very careful at the short term in between so that we don't leave people behind.
Patrick?
I would say it will open a lot of opportunities. The question is, who will have these opportunities? Who will be in control? Because it can be opportunities for everyone to enlarge, in fact, your perimeter of life, to your perimeter of things, of experience of life you can have. Or it can be improve the opportunities for a few ones to control the rest of the population. So it will be opportunities. Okay, we have to...
What will we do with those?
What will we do, and will we be shared between all the population or not?
Joanne?
For me, there is a risk to avoid is that the machine will take all the decision, and so we need to take out the responsibility of our own decision and not the machine.
Joanne, one sentence in closing?
Yeah, I agree with Patrick. I think we must be very aware with common sense by repeating what we did before, just having a look to what is happening now, that is, who has the power to who is the owner of these tools with a big dependency of it, and how can we regulate that in each of our cultures in the same way that we always did it, without to be at a state where we cannot
Come back.
Yes.
The point of no return. Thank you very much. As you can see, I think we opened up more questions than we provided answers, but nonetheless, you can see that there's a real need coming from government, coming from the corporate world, coming from academia to find solutions to this huge framework that needs to be solved so that things don't spin out of control. At this point, I'd like you to give a big round of applause to our panelists. Thank you very much. You can take your seats. So we've seen that there's a lot of ethical concerns surrounding AI. We haven't answered all those questions. Nonetheless, at this time, we're going to move over to the business side of things. And at this time, I'd like to ask the CEO of Applied Materials to join me on stage. They are the world leaders in engineering solutions for materials, for both chips and advanced display. At this time, I'd like you to help me warmly welcome Gary Dickerson.
Can you hear me? Is this, okay, there we go. All right, well, thank you very much. I'm really excited to be here today at the Leti Innovation Days. Who out here thinks it's the best time ever to be an innovator? Raise your hand. Who doesn't think it's the best time? No, I really do believe that the opportunities have never been better, and the challenges have never been bigger. I think it's the best time ever to be an innovator. It's the best time ever to be an innovator in Europe. It's the best time ever to be an innovator in Leti, and the best time ever to be an innovator in applied materials. I really deeply believe that, and I'll talk about why I think that's the case. So if you look at the history of computing, we went from mainframe computers to PCs, where everyone has a computer on their desktop, to mobile social media, where we all have computers and cameras in our pockets, to AI big data. And AI big data will transform all of our lives, create trillions of dollars. People talk about $10 trillion in terms of the economic value opportunity over the next 10 years. So there's no question. Biggest wave of our lifetimes, the most profound impact on all of our lives is right in front of us. And people talk about data really driving the next industrial revolution. In the past, it was oil, but you also had to process the oil to unlock the value. The same thing is true with data and the data economy. If you look at the companies that are growing the fastest today in terms of market caps, all of those companies are data-centric companies. And we're really, really just in the early innings of this big wave that will change all of our lives and create tremendous economic value. And in the future, every business will be a technology business. Every business will be a technology business. Agriculture, transportation, democratization of healthcare, early detection of issues, health issues, creates tremendous economic value, but also it has a profound impact on all of those lives. And also the democratization of healthcare, democratization of education. Education is another area that across the globe can unlock so much human potential. So again, all of these businesses, every business will be at its core a technology business and part of the new data economy. So if you look at all of the connected devices, people project that there will be 1 trillion connected devices in the next 15 years. Explosion of data. So what happened in 2018 for the first time? For the first time, machines generated more data than people in 2018. And if you look at the projections going forward, data is going to increase at a significant pace, but just in a few years, 90% of the data will be produced by machines instead of people. It's really a profound change in all of our lives and growing at a tremendous pace. And then another change is shifting from general purpose computing to workload-specific computing. So at the same time that we have the biggest opportunity of our lifetimes, we also have the biggest challenge of our lifetimes, and that's why, for me, as someone who loves innovation, I deeply believe this is the best time for all of the innovators to create value and have a meaningful legacy in terms of the world that we leave behind. So if you look at general purpose computing to AI computing, there are big differences. Parallel computing, high-speed memories, and lower precision. All of these changes are why you see GPUs and TPUs growing at a very, very fast pace. But what I'll talk about later also is a big challenge we have, not only in enabling the infrastructure for the data economy for economic value, but the power consumption, power efficiency is a tremendous challenge that most people don't understand. So the innovation certainly will unlock tremendous economic value, but in terms of sustainability, it's also critically important that we innovate. The future of computing, storage, connectivity is not a linear path. It is not an incremental linear path. It requires tremendous innovation. So this was an article that came out here recently from MIT. And basically, in their lab, they were working on language processing, language neural net. And what they noticed was that the energy bills were tremendously high. This shows a comparison in terms of power consumption. So what you can see is the training AI model at 626, a car in its entire lifetime, about 5 times less, the manufacturing, fuel consumption. So you look at, again, the data economy, data exploding, economic value being created, but power consumption can be a limiting factor for this future. And then you also have this comparison with a round-trip flight. But this is something that not many people are talking about, but it is an enormously important area for technology innovation, for sustainability. So, if you look at some different comparisons, security cameras with CMOS image sensors, processing, storage, network connectivity, temperature sensors, generate about 5 to 8 watts for each one of those security cameras. If you deploy 1 billion of those security cameras, you consume about 25 terawatt hours of power. And one thing I know from our business within applied materials, and I'm sure you can see in all of your lives, sensors are exploding everywhere. So power consumption for sensors will be a big issue for sustainability. If you look at today's data centers in the United States, they consume about 90 terawatt hours, and the average nuclear power plant produces about 10 terawatt hours. So within Applied, we've done studies. I'll be talking more about this at a conference next month. But what we see is a tremendous increase in power consumption if we don't invent the future of computing. It has a profound impact on the economic growth and a profound impact on sustainability. So just by 2025, taking the current compute methods would consume about 10 to 15% of the world's power. And if you extrapolate out into the future, as all of the industries are being transformed, all of our lives are being transformed, obviously this has an enormous impact. It has an enormous impact. And I would say that for me personally, certainly the $10 trillion or $13 trillion, the economic value that we create is enormously important. But also, like many of you, I have children. I have my twins just turned from 9 to 10 last week, a little boy and a little girl. And I deeply want to leave a better world behind. So it's important, tremendously important, that we drive this innovation. And as I said, I deeply believe it's not a linear path. It is definitely not a linear path. So if you look at cloud, edge, training, and inference, to get where we need to go, to deliver the economic value, to deliver a sustainable future in terms of power efficiency, we need tremendous improvements in the cloud and in the edge. In the cloud, maybe 1,000 times in terms of performance per watt improvement is necessary. And certainly all of the cloud service providers are working on those innovations along with many companies, including many startup companies. And in the edge, there's also a need for tremendous innovation and orders of magnitude improvement in terms of performance and power. And the edge will be everywhere. And the edge creates opportunities for many, many, many companies, including some of those that I've seen here in Europe that are associated with Leti and a part of the overall technology ecosystem. Tremendous, tremendous opportunities. As I said before, never, ever has there been a better time to be a technology innovator than today. So, Moore's Law. How many people think Moore's Law is not dead? Raise your hand. Okay, a few of you. I would disagree with you. Moore's Law, the playbook for Moore's Law really created phenomenal changes in all of our lives. Incredible. I show this iPhone. If it was built in 1980, you'd have an iPhone that's 14 meters tall. I don't know how many of you could be carrying that around. Consuming 600 kilowatts and cost $110 million. I would guess not many people would be buying many iPhones with those kinds of characteristics. So Moore's Law really changed all of our lives. We're all connected. We all have all of our memories that we can capture every single day by the devices that we have in our pockets. I mean, it's really, really, really tremendous, the economic value that was created. But I think it's also clear, if you look at the rate of technology improvement, that Moore's Law has been slowing, and the current playbook is not going to get us where we need to go. And it certainly is not going to get us to a sustainable future and unlock trillions of dollars of economic value. We can debate that, but I personally think that's very, very crystal clear. You can look at the curves here. You can look at how long it takes to bring new technologies to market with power, performance, area, and cost. And the current playbook will not deliver where we need to go for the future. Again, if you're an innovator at Leti, Applied Materials, an innovator here in Europe, now is a great, great time to deliver innovation and a new playbook. So let's talk about the new playbook. In the last month, I've traveled 20 days. I met the R&D leaders of all of our key customers in Taiwan and Korea and the northern part of the United States. All of them met many, many hours of meetings in the last month. And what I can tell you is that every one of them is driving to speed up the technology roadmap, and every one of them also believes they need to think differently and act differently to drive innovation within their companies. Every single one of them. So let's think about the new playbook. And again, this is very consistent when I talk to people through the whole ecosystem. New architectures, new structures, different ways to build devices, especially 3D. We saw that with 2D to 3D NAND. I am extremely confident that there will be innovations that aren't visible today that will happen faster than people think in new structures and new materials. New ways to shrink, new ways to place features where you want them on chips, and new ways to connect chips together. All of these areas are part of the new playbook, beyond Moore's Law. And for me, within Applied Materials, what I'm very excited about is it's all based on materials innovation. And for me personally, I've never had any more fun in my entire life because again, the opportunities and the challenges are bigger than we've ever seen. And this new playbook is really essential to get where we need to go. So if you look at different types of devices, there are many, many different technologies here, and there are some that aren't on this list that will be very, very, very important for the future. And within Applied, we're connected across the ecosystem with many existing companies and new companies to work on enabling these new technologies, these new device structures. But all of this is important to get where we need to go with the edge and cloud for this new big wave that we've never seen before. So within Applied, one of the things I'm focused on personally is driving speed of innovation. My goal is 10x faster than where we've been. But again, for us within our company, I am 100% certain we will not get where we need to go doing what we've done in the past. You can't get to 10x faster by small incremental innovation. You have to rethink how you work. And those are things that we're driving within the company. But I think also what's very, very, very clear is when you think about the whole technology ecosystem, from materials to unit processes like creating a film, modifying, shaping a structure, analyzing a structure, going to new interconnect technologies, transistor technologies, image sensor technologies, new structures, new packages, how I connect all of that together, new designs, and new systems, software and hardware. What's very clear to me, and I tell many people, that I've learned more in the last year about what I didn't know than in my entire life, which actually I think is a good thing. Because if I wasn't learning how to do something different, we would only be driving incremental progress. But I deeply believe that collaboration and also bringing different skill sets into our company has made a tremendous difference in us being able to see how we can integrate all of these processes together to deliver new structures, and the importance across the entire ecosystem. And again, the language, the requirements, co-optimizing that in parallel is enormously important to speed innovation to deliver the orders of magnitude improvement that we need. From materials to system, going from a von Neumann type of a thinking process, serial improvements, to parallel, neuromorphic ways of thinking. So I think whether it's applied materials or Leti, across this entire ecosystem, the companies that will win are the companies that collaborate better and faster than others. I really deeply believe that. We will not get where we need to go doing what we've done in the past. So, Applied's investment. Right now we have a market that is softer than it's been, although if you look at the current investment in the semiconductor business today, where we're at this year is higher than any of the peaks from 2000 to 2016. So it's still a very strong market, and I think that part of this is because we're in the early innings of these new technologies. We're seeing an explosion of sensors. We're seeing IoT, communication, automotive, power, sensors, many of those markets much larger than they've ever been. And that's helping to stabilize the market as the memory business is lower today. But again, we have tremendous point of view relative to the future of this business. We believe that it's going to be bigger, stronger than it's ever been. So I think, for me as a CEO, what I think about is it's very important to have a point of view and courage to invest. So we're investing more through this time period right now. And I would say that for me personally in my career, I have done the best in soft markets and downturns. That's where you prepare for the future opportunities. And as I said before, I believe the future has never been better, and the need for innovation has never been bigger than what it is today. So at Applied, we're continuing to invest. $2.1 billion in R&D, the Made in Technology Center. We're launching a materials engineering technology accelerator in 2019. We just opened, I was in Taiwan a few weeks ago. We opened a new display lab with the most advanced displays in the world, the equipment coming from Applied Materials, from that R&D lab and also the manufacturing center that we opened. Packaging, heterogeneous integration is very, 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 very important. If you look at GPUs today, one of the innovations that's happened in the last few years is combining GPUs with high bandwidth memory in a package. So what value did that create? Basically, through that package, it was about 3 times faster and 50% lower power consumption. There's still tremendous opportunity for innovation, still a tremendous opportunity for innovation in packaging. Applied has the most complete and innovative packaging lab. We can build all types of packaging technologies complete from one end to the next in our Singapore lab. And we have tremendous collaborations with very big technology partners on some of these new packaging technologies. And then Applied Ventures, also making investments in startup companies. I know Leti is partnered with many new technology companies. Our focus is really how can we help those companies accelerate risk retirement and grow faster. I mean, that's really what we're focused on. Not a passive investment, strategic partners with technology innovators. So we're investing more in these areas. We opened a fund in Taiwan. We have a fund in Korea. And again, partnership with Leti and others in some of these new areas. So 30 years we've been working with Leti. And I want to say, from my perspective, as I said before, technology innovation has never been more important. There's never been a better time than today. And certainly our partnership with Leti over 30 years has been a great partnership. And I think the future is so much brighter in terms of this relationship. The strategy, the leadership, the talent within Leti is really world-class. And, for me personally, I love being connected together and collaborating. And really, I look forward to creating a better future together. Thank you very much.
Thank you, Gary. So we know here in Grenoble we have the habit to celebrate the partnership, the 30 years partnership. So let me offer a wafer produced somewhere here with your machine. Thank you so much for your partnership.
Gentlemen, on your long-standing partnership, we're now going to move to the subject of chip architecture. Machine learning and artificial intelligence have made many breakthroughs in a number of fields: image recognition, healthcare, driverless cars. Of course, this means that we're going to have many new challenges in many other fields where there will also be breakthroughs very soon. So, huge opportunity and challenge in terms of chip architecture. At this time, I'd like to invite Shekib Akrutz to join me on stage. He's the Vice President of Strategic Programs at Synopsys, a leader in applied testing, application security testing.
Whatever you say, it's a great answer. Thank you. Appreciate it. It's really a pleasure to be here in Leti in Grenoble, even though with very uncharacteristic warm weather. By the way, I love the talk from Gary Dickerson and the optimism he kind of really deployed about the future, where we're going, and the future of the technology. And the thing is like Moore's law is not, it's maybe dead, and there is something else, like packaging will solve the problems. I'm going to talk about something about AI, maybe in a different perspectives. So the first things I'm going to say in the same kind of optimism way of thinking, in 2017, we've counted $17 billion worth of investment just on AI startup company. We don't know the number in 2018. We believe the numbers has been maybe stabilizing and maybe growing a little bit. But the investment is continuing. And I always like to start my presentation about AI, talking about AI definition. And you can imagine about having all of you guys maybe expert or knowledgeable on AI, why we start with the definition of AI. And the reason I usually go through it is because there's always this question, is that a hype? Is that a wave? Is that going to have another AI winter coming? So always we have this question in the back of our mind. And I felt like when I look at the definitions, it does give kind of an answer. It's really about science. As any science, it's actually multiple discipline science. It's going to continue evolving, and this is the way how science evolves. So when we talk about like less investment, more investment, it's more like financial or economic kind of way of looking at things. But as AI, if you think about it as a science, it's going to just continue evolving and progressing. It's really developing and implementing methods and systems that manifest cognitive behavior. It does have feature, learning, generalizations, inductive and deductive reasoning, human-like communications. And it also has actually future which is right now in progress, like consciousness, self-assembly, self-reproductions, AI, social network. And there is this actually questions at the panels. What's AI kind of really reach the human intelligence? And actually, the future of AI, there is a name of it. There is a definition. It's called singularity. Singularity is the same definition of the singularity we think about at the end of the black hole, where all the law of physics kind of breaks. So that's where when we think about it, what would be kind of the future of AI? So the definition is definitely the AI will reach the human intelligence. And actually, the definition goes even beyond that. It's more mathematical definitions where there's this kind of exponential increase of intelligence. So that's the way how it's been defined. And when I look at this kind of really evolution of substrate where things has evolved, we get to the brain and we go to the digital, which we call it like the information world, where everything is being considered as informations. That's the meaning of data. That's the way how we end up looking everything's even in the law of physics today. But that's where we define where AI it's going. So now, when I really try to understand, okay, what is this data? What is this algorithm? All these kind of mathematical models we put in place, it always gets me to think about the Platonic solids. I'm pretty sure you know what's about Platonic solids. We only have 5 of them. And we never understood why. It did bother many of the mathematicians for many, many years, like a couple hundred years ago. To the point where they thought this is where it's really the composition of everything, and they named them, right? They named as the fire, the earth, the air, the water. And the 5th one, they couldn't name it anymore, so they call it ether, which is really the universe or heaven or whatever's. And that's what's, I would say, the natures will give us across all these data, which is really getting me to think about that's maybe what's the nature is given us as AI. So now, let's go think about what are the future challenges and opportunities which we are going to see in AI. First of all the data we're having are more statics, where in reality our world has time on it, so things come to us in time. So that's where they define the SNN, which is the spike neural network, which I'm pretty sure you heard about. This technique actually is being used in some areas, and it's given quite of good results. AI learning from other machine learning behaviors, either generating data or learning from it, like think about the machine learning supervisors, like really supervising all these machine learnings. Predicting and explaining, that's a big challenge. You heard about also in some of the discussion in the panels or some of the presentations. It is actually a big problem, specifically on these deep learning neural network, where we don't really understand what's happening inside, which they call it like the black box. So that's actually a challenge which can help us figure out how to evolve from that to have explainable AI. Computation kind of complexity. I'm pretty sure you heard about the P versus NP and the SAT problems. All these kind of advanced algorithms kind of continue advancing, and we kind of continue solving problems. And machine learning may move actually some of the hard problem to an NP problem, or maybe some of NP problem to the P problems. The probabilistic aspect of quantum computing, which is really mimics some of our way of thinking. We think with probabilistic things. We are not really deterministics. And quantum computing may provide some possibilities there, as well as the new architectures. You heard about the neuromorphic versus the von Neumann kind of architectures, which is definitely mimicking the brain and the human being. So now, when you think about AI, there are many different domains. Some of them actually has gotten quite of a good advance, like self-driving cars. We are pretty much in level 3 right now. Hopefully we'll get to level 5 one day. Speech recognition is also going very well. The gaming has actually gotten the most impact on us when we starting getting to win against the master of chess, or when we won against the AlphaGo. Actually, the AlphaGo, it's like an ancient Asian kind of games, very simple, but the number of combinations, it's beyond this word. It's like 10 to the power to the 180s, which is, all of us believe there is no way to have any computations capable, or any computer capable actually to go through all the combination of it. However, when we get to the machine learning, it's a combination of many different techniques actually is being used to really beat all the human being. It did really impress many of the Asian world. And actually, this is a time where China has decided to really put and triple the effort on AI, just kind of by seeing how machine learning could have that capabilities. And we've talked about many other areas. I think the most, at least impactful one, in my personal view, is the healthcare. Hopefully, one day AI will help us, given us capabilities to be able to solve and get a better healthcare, which is actually, as you know, the cost of healthcare is now increasing to the point where we need to do something about it. So now, let's go back to our domains and where Synopsys plays. It's really on the AI design. So the AI design consists of bringing intelligence to kind of really designing chips. And our ultimate goal is really be able to have, you can think about it, autonomous design, where we can apply machine learning and AI across all the different steps of the process to develop chips. And that's from the system specification or from the architecture definitions to even getting to test the chips at the end. This is where we at Synopsys looking at what we can do, since as a provider of tools to help designing chips, in terms of how to augment that capability. So the couple of things which we are trying to look at, it's, and these are not like all the list, but which we believe the most important one, we believe at the yield. Yield is very important. It's actually getting more and more difficult to kind of really play with the variability we have in the node, especially when we go beyond 7 nanometers to go to 5 or 3 nanometers. The data are theirs, the computation are there, so we can really provide more capabilities and more help there. And as you know, yield is very important for all companies, because if you improve the yield, that goes straight to the bottom line, straight to your gross margins. Design resources, actually many of these chips are getting very complicated. These design groups are very big, they are global now. Actually, with even the explosion of AI design, there are more and more demand of AI designers, and we don't have enough AI designers, so can we really provide capabilities there? I think this is also something we are looking at. Chip performance and chip power is still the number one, the top of the list in terms of what you want to try to improve for your chips. You've heard about the low powers, the ultra low power we need. but performance is still also part of the equations, and we are far away to kind of have the models of big chips or even understanding how to tune performance of big chips. Therefore, there are much more capabilities here we can provide with AI. So now, if you look at about Synopsys per se, how we bring these, which we call it like really intelligence amplifications versus artificial intelligence, we try to implement AI, first of all, in our tools. So we want to have our tools more capable. Actually, we are getting quite of good results already by applying some AI in some specific tools. By the way, in some other tools, we are applying AI, and we're not getting good results. And we don't understand why yet. So it's kind of work in progress, but it's definitely given us a good result in some areas. We try to accelerate our quality of results. We try to implement AI on validation and verification, which is also an important subject in terms of really validating and verifying chips. There are a lot of data there also available, so we are also applying AI as well there. Also to optimize power and performance, I mentioned, and also trying to kind of actually provide, I would say, cloud with AI capabilities to differentiate from the public cloud. So we're not really implementing cloud to be a cloud providers as the public cloud, but more specialized cloud, which will have more capabilities for, I would say, chip design companies to be able to develop their chip on the cloud. But we are providing, and we are thinking about what can we do to make some differentiation on these clouds so it becomes much easier and much more capable to move your design in the cloud at Synopsys. Now, we're also looking at the new tools in terms of actually helping many of these AI chip developers. These AI chip developers, most of them are startups. They may know their application, they may know their software, but they're not like chip designers. So actually, they came to us and asked for help. Can we help us developing chips? And when we look at these AI chips, they're not like any kind of all chips. Like, it's not like a complete microprocessor or graphic chips. They are very repetitive structures to do your matrix inversions or whatever way how you do your algorithms. So we're trying to start thinking about developing new tools which are capable to actually capture an application at the high levels, and from there, we take it from there and we kind of get through all the implementation until to the RTL to even the implementation of the chips. So it's work in progress right now. It's happened in the AI lab. We call it Synopsys. We are making progress. We're not there yet, so we're trying to make sure this is going to work. But I believe we have a shot. If the structures and the design is not maybe highly demanding, we may be able to provide that capabilities. Also, we are working on machine learning infrastructures. Anybody who try to implement machine learning, they have to deal with data. Actually, most of the time is being spent to clean up the data, figure out what to do with it, how to store it, how to collect the data. So we're trying to develop new tools. Actually, this tool is for our internal use, and hopefully we get it to the point where it becomes mature enough so we can provide it to our customers and outside customers. And we continue expanding in our autonomous design, which is hopefully our ultimate goal in terms of providing all this capability to develop a chip and maybe more AI chips. Now, if we step back and we think about how all this machine learning and AI is making progress and what are the opportunities. So there are actually 4 of them in my mind. There's actually a 5th one. We call it like a biased data. This is more related to the ethic things, but I'm not really going to go after that. I think you guys heard about it quite a bit in the panel. First of all, most of them are supervised learning. Actually, more than 90% of the machine learning are supervised learning algorithms, which means you give the machine the input, but you tell her what's the output, and this is the way how it gets to the learning. And therefore, you need to label the data. And labeling the data, it's getting bigger and bigger every day. So, and that's getting a problem. So there is a way how to get around it. People are trying to use reinforcement learning, which means you don't tell the machine exactly the answer, but you tell her, is it good or not good? Then the machine tries to develop a policy behind it. Or like in-stream supervised and unsupervised learning is also being pursued to get around that. Explaining results, as I mentioned, this kind of black box, non-explainable AI in some domains is not acceptable. Actually, in healthcare, doctor doesn't want to hear about any kind of prediction or inference if they don't understand why. For them, it's just pure like statistical correlations, does not have any values. In our engineering domain, the same things. In many other industries, they also have the same need in terms of really explaining that AI. Way how to get around it, simplify the network, limit the number of features, that could help, but we're not there yet. Large data set. You've heard about it, privacy and availability of data in some area, in some domains. We will not be able to access to the data for privacy reasons, for legal reasons, for whatever right reasons, either the data exists or do not exist, it's going to be limited. And that's going to be a big, actually, limitations. There is quite of effort there to figure out if we can learn by analogy with the small amount of data. There is also now machine generating data. Is that valid data? It's a good question. It depends on the domain. And the last one is generalizations. Anything you do in machine learning, you always end up doing a generalization. That's the ultimate goal. That's what will allow you to do the inference. And therefore, it's very important to do that generalization right, not overfit or underfit the data. And that's really requires like a heavy trainings with more data. More you get data. Now we're even trying to do learning at the edge with always also limited amount of data, or you don't have enough compute. So generalization, it is actually quite of a big challenge in front of us. One way to get around it, again, need to transfer learning from one set of data to another's. It's going to get us there or not. That's going to remain to be seen, and we'll see how much progress we can make. So now let's kind of go and jump to this AI chip architecture. So this is the way how all these AI chips right now are being architected. And actually the list is getting further on the right in terms of more things we are seeing coming out. But first of all, machine learning has been applied on the CPU. That's immediately where we apply it, because that's computers we have available on us in our hand. Then we went to the GPU, which has more capability actually, and it's more kind of suitable to that kind of algorithms. And you can see in the bottoms the performance per watt. If you put one on a CPU, you get 3x more performance per watt in the GPUs. Now, if you go to the special kind of chips like FPGA or special ASICs like the TPU, which is being developed by Google, then you get to the 100x. You jump really very high. I can tell you this architecture has continued evolving right now, and it's progressing. It's extremely difficult to follow everything's happening in the world. We even have specialized people now looking at all these kind of different innovations. But this architecture is going to continue evolving, depends on what kind of algorithms and how the algorithm is been evolving, and try to apply it there. But there is tremendous, actually, capabilities you can get out of it by specializing your architectures and continue improving it. Now, when you think about what will drive more new AI chips, yeah, we know about more applications, we know more availability of data, therefore there's going to be more need to develop new architectures. But when you try to really compare where we are in terms of artificial intelligence against human intelligence, that's the structure that come up with it. So first of all, artificial intelligence is very data hungry. Human, we can learn with very limited data. If you try to learn how to drive a car after 40 hours of driving, you can learn how to drive a car. Actually, Tesla right now has a fleet of 100,000 of cars running all across the globe, and try to learn from all these cars, and they are barely at level 3. They developed actually a nice chip in Tesla, which they disclosed recently, very specialized, very nicely structured, capable to handle the right kind of data needed to be collected by the car to be able to do self-drivings. And like Elon Musk said, oh no, it's a question of software, which means how it's really the algorithm is going to work with it. Human beings have hierarchical thinkings, and so far right now, everything we do in these algorithms are really flat thinking. We don't know how to deal with actually causation from correlations in the machine. It's purely correlations. That's the only things we know how to do. It is statics and bias, where really human can recognize the world around us is changing. And that's really actually which is right now being seen in the self-driving cars, where if the cars have not seen that scenario, doesn't know how to deal with a new kind of world changing around us. Lack of accuracy, we're always trying to improve our accuracy in the machine learning. So the human being has figured out how to trust actually approximations. And it's another level of thinking, really. Which is get me to really think about what I call it the common sense and the reasoning on AI, which I believe that's the next level. That's where everybody is going after it. And that's what we need to kind of really develop. What kind of technology we have in our hands to be able to really get us maybe close to that. Deep learning, it's really give us quite a jump recently with all the data and the computation capabilities. Reinforcement learning is actually another algorithms. Also the Bayesian algorithms, which is more based on probabilistic kind of approach. It's right now more like in a wave in terms of what kind of new algorithms is being used. New insight and advanced algorithms, that's very, very important actually. That's the way how we put our knowledge, our expertise in our algorithms, because that's what gets us to what I call the explainable AI. Performance leap from quantum computing. Many people think quantum computing is far away. Maybe it is. I can tell you, like last January in Las Vegas, IBM has announced the first quantum computing is available in the cloud for actually more the academia to kind of learn how to program the machines. But the machine is there. We may not completely know how to program it yet. We have a good understanding why it's working that way and how it works. But it is getting much closer than what we used to believe, even a year or 2 years ago. The other actually technology which will also develop and push for more AI application, 5G. 5G will provide more real-time data. With more data, we can definitely kind of increase the number of applications, the number of capabilities. Silicon photonics, that's get us to more performance. We would need that performance with the less power possible, specifically on the edge. Actually, power is also important in the cloud. And the new architectures. I really believe the neuromorphic architecture is the way to go, even though we kind of maybe not define it well, but this is what will mimic the best our brain, our human capabilities. Actually, I like the answer about human. We never get too close to humans, and maybe AI, yes, may not get to human, but in some applications, it will give us all the amplification we need to do much better work than anything we can do. And that's what really will drive all these new architectures. I always finish by this, what I call it the big AI elephant in the room. That's the way how we need to really think about it. It's so easy to say, I have data, I have an algorithms. Oh, okay, let's have an outcome and let's go from there. On that, thank you very much for your attention.
Thank you very much, Shakib. So you've heard about data chip architecture, and this morning we had the 10-year vision of Leti, and you see that with all these new applications, we're going to have to make progress in hardware. So at this time, I'd like to call on a specialist, an AI specialist from CEA-Leti. LIST is a CEA institute which is specialized in digital systems and a close partner of Leti. Please join me in welcoming François Thirier.
Okay, thank you. It's okay? Yes. So the talk is about safety and artificial intelligence. So the context is embedded artificial intelligence. And as you've seen, there is a lot of opportunity for embedded artificial intelligence for various domains. And in these examples, I want just to underline some points. For the same domain, for example, automotive, in fact, it concerns several functions, not just one, which could be autonomy, but assistant to the driver, recognition of people, and so on. a lot of some other domains are interesting, like here it's for fleet of drones coordinations. We talk not often of these subjects, and it's clearly one important also subject for embedded artificial intelligence. So what we have to have in the mind is there is a lot also of functions. I will not talk about intelligence, but mainly functions. It is what we consider, and what is interesting for us is to make control, diagnosis, perceptions, decisions, or consensus for distributed decisions. And all of these applications are in some way, and sometimes very strongly, trust-sensitive applications with strong expectation from the user and from the market on trust that concerns safety, reliability, security, privacy, and a lot of other aspects related to trust. I will not detail all the things due to the time. This technology is coming, it's clear. We have a lot of examples, but it's also clear that the technology comes with a short maturity, with clear weakness, both on usage, specifications, design, robustness, security. So all aspects of the development of this technology comes with some weakness somewhere. And one common observation on this point is that, in fact, the development process are not under control. So we know how to develop some artificial intelligence, but the process itself is not very well controlled. Some people said it's alchemy. Some others said we have the artifact, but we don't have the theory to understand how they work, what they can do, in which context they can be applied. Clearly, for machine learning, but also for other kind of intelligence, it's generally associated to informal requirements with a set of examples. And it's developed by trials and error, and at the end, we have a poor justifications and explanation of the results. If we compare to the process used in safety-critical systems or just systems on which we want to have a good quality of the product, we always start by requirements. We decompose the requirements into functions, sub-functions, actions, and at the end, we are able to justify each instructions, each value has to be refined from the initial requirement and justified to the standards and so on. So this is the clear difference between both approaches that leads to this problem of development process. We have to really have in the mind that this process breaks all the conformity assessment principles and processes existing at this time for embedded systems when we have to assess the quality, the safety, the security, and so on. And it's really a question to say, are we in front of a third artificial intelligence winter or not? The question is open, we will see. I don't say it's the case, but we have to take care about this. And to take care about this, we have to think about the trust, because the trust on this system will make the difference, will make the acceptability of the systems by the users, by the market, we make acceptability of the systems by the society, the certifications bodies, and so on. And this subject is really taken into account by several bodies. In Europe, we have guidelines, but what one other things important that appears in the last months is also guidelines from the OCDE. So we see that in the world, this subject starts to be considered very carefully and providing guidelines. At this time, it's generic guidelines, but it is the first steps. After, we have also to consider the whole systems. It means, first, we have to think on the applications, to imagine the new applications. It's not clear what will be the best application for artificial intelligence. And we have to understand the real need of these applications, not just to make machine learning because it will provide some results, but really to think about the needs and these applications. After this application, we have to design, to verify, and to certify them. For this, we need tools and new processes. And we have to deploy with technology, hardware, software, with good performance and cost on these solutions. It's crucial, and we have heard a lot of proposals and vision about this point. So I will continue on this aspect related to the process. I will start to give a very fast look on what's happened in the world. So in France, the French Ministry of Defense have given some discourse saying we need to have robust artificial intelligence and certifiable intelligence for all systems in the domain of defense. It's a really a strong requirement from this ministry. If we look what's happened in US, DARPA has launched several initiatives related to assured autonomy, explainable artificial intelligence, safety and artificial intelligence, and so on. I have mentioned also the UK government of defense that have pushed some actions on this track also, and who work in some international working group to see how to progress on these subjects. At academic level, it's also a strong trend. We have seen some great academics who created dedicated research center on safety for artificial intelligence. I have just mentioned some there. We can see that in Stanford there is 2 centers related to different aspects, but both focused on artificial intelligence safety. It's really structural. At the CEA, we have also launched recently a new program for trustworthy artificial intelligence. And there is a lot of others in the world. On the industry side, it's the same things. Thales communicates strongly on trustworthy artificial intelligence will be a key topic in the year to come. And it's done in several times. We find some other examples in large industry. I have just give some examples. It's just to see its world trends. So how can we reestablish the trust with for safe artificial intelligence? So it requires some coordinated research and development on several branches. One aspect that have not to be forgotten is to deal with symbolic artificial intelligence. It means rule-based artificial intelligence, constraints-based artificial intelligence. This technology is very mature, very ready, but the inference engines or the solver are not ready for embedded systems. They have been built for general purpose applications, and we have to work on this. For example, to build proved by constructions, solvers, and inference engines compatible and with a small impact into memory to be embedded. We have also to work on process. I have insisted before. This is one subject on which we have started to work for safety evaluation process for system, including both classical applications, classical software and systems, and artificial intelligence. And it's underlined that in this process, we have now also to take into considerations ethics aspects, because ethics will modify the design of the system, will introduce new functions, new requirements that complexify the systems and that have to be integrated, in fact, in the general safety evaluation process. We work also on formal validation of machine learning based artificial intelligence. So this point is quite important because at this time to validate machine learning, it's mainly based on test, empirical test, and the question is the test database representative, valid? Is the result trustable? So now we try to move and to say, okay, we will work to demonstrate what is the domain of evolution of the systems and to compute if the answer of the systems will be always acceptable or not. It's quite complex, but it's one subject on which we have a lot of background. And also we work on adversarial attacks to check robustness and explainability, which is also clearly an important subject. But don't mix explainability and safety. If the explainability is a proof, okay, it's an element for the safety. If the explainability is just a function to give some intuition of what's happened in the systems, so you can use these intuitions to assess the safety of the systems. So all of these points are important, but not sufficient, one separately from the other. So to conclude, the idea is to really to say that safety of artificial intelligence could be a showstopper for the disseminations of embedded artificial intelligence. And it's urgent to understand what are the behavior of artificial intelligence components, to formalize this behavior, to formalize their requirements, their property, and the development process. So trust will be built on more understanding on what happens. The neural network cannot remain a black box. We have to find a way to assess their functionings. Even if they are by some way a black box, we have to formalize how they run and what are the entry and the output. For this, we have to build some and structure some ecosystems, both on local side and on international side. It's something we have started to do. So inside DataIA, near CEA-Leti, we have launched a working group for safety and artificial intelligence. And another action has been launched at the international level to create some working group on safety and artificial intelligence, and in particular to create a body of knowledge on all the essential elements we need to work on these subjects. You have an example of the actors that claims to be interested to participate on this working group. It's open, so both at local, national, and international levels, all these working groups are open. You can contact us, join the work in order to progress on these subjects. Thank you.
Thank you very much, François. Thank you very much. Today, you've heard about lots of serious, well-established players in AI, but big question, what is the next generation working on? So now we're going to hear from 4 young and talented scientists who are going to pitch their fresh ideas. Our first speaker is Nashwa. Give her a round of applause.
Ça marche pas.
Good afternoon. Okay, so again. In my hometown, we say, cooking is the way to a healthy life. But what can we do if we don't know how to cook? According to a recent survey, nearly 60% of young adults, they leave parents' home without ability to cook 5 simple dishes. Without the ability to cook 5 simple dishes. I think we can help them. We can help them by bringing a coaching system into every kitchen. As a computer vision scientist, I believe that we can do an AI system that coach us in the kitchen and understand, analyze, and understand our actions in the kitchen by what we are doing, the object that we are trying to interact with, and tell us what should we do and what should we do next. In my PhD studies, I work in the visual recognition of the system. Visual recognition of actions is kind of a challenging task because the same action can be done differently using different people, by different people, and the same person can perform the same action differently over time. In fact, previous methods of action recognition have mostly concentrated in learning the spatial temporal patterns of motion and associated with each action. But manipulation actions has a neat property. They transform the action. The actions transform the objects from one state to another. Let's take a simple example in the cooking domain, like, for example, slicing a cucumber. Slicing a cucumber is, we can slice cucumber with many ways. We can slice it using a knife, using a mandolin, or using a food processor. No matter how we do it, all roads lead to sliced cucumber. But what does not change, in fact, that before doing the action, the cucumber is in the whole state. And after doing the action, the cucumber in the sliced state. So, I know what you're thinking, but yes, there is a connection between sliced cucumber and my PhD, and here it is. In order to recognize manipulation actions, why not track manipulated objects, such as the cucumber, and their transition of their states over time, and use this to detect manipulation actions? So, in fact, to study this question, I built a deep neural network model that learns to detect manipulation actions, and this over time, and it detected using transition of states. This model was successfully detecting manipulation actions and using very few number of frames, and still achieve competitive results in the domain of action recognition. Even though I mentioned here only coaching system in a kitchen, but do you know what else we need coaching for? Everything, from replacing a tire to assembling a furniture or a car. We could all extend our set skills using such a coaching system. And this brings me to my last final message. With some clever ideas, we can transfer our intelligence into AI intelligence, and together have AI systems that assist our lives and makes our lives easier. Thank you.
Thank you, Nashwa. Our second speaker is Thomas. Please give him a round of applause.
Let's see if this, it works. Okay, good. Okay, so we're all here for this series of workshops and plenary sessions because we all anticipate the impact that artificial intelligence can have in technology. In a general sense, machine learning models are mathematical optimizations that minimize some measure of error or maximize some error of score given some data and an application. This process is often called learning in order to liken it to the process in animal nervous systems that contributes to their intelligence. However, it's often too easy to forget that intelligence in animal nervous systems is more than just learning. This is particularly evident in smaller, simpler organisms, for example, insects. Take as an example the fruit fly, Drosophila. Immediately after the fruit fly is born, it can already extract useful visual features from its scene and use these visual features to control its motor system to fly around. This behavior is not learned, but instead is innate and built in. It is built in to specific neural network topologies and neural dynamics that have been carved through millions of years of evolution and arrived at highly efficient solutions for problems we are currently trying to solve with often inefficient machine learning models. So as engineers and computer scientists, we have to ask ourselves, how can we transfer these principles observed in animal nervous systems like insects to useful computing hardware? The answer begins in a revolution in the hardware. Instead of distinct information processing and information storage centers, instead we have to find a way to distribute processing and memory through an entire computer system where the two are co-localized and ideally indistinguishable. And this is the point where I work here in CEA-Leti. I look at the nervous system of animals, in particular of insects, and I also look at the semiconductor processes we have at our disposal and look for ways to reconcile the two into some new kind of useful computing hardware. In particular, I look at hybrid processes, which are processes where you can integrate non-volatile resistive memory technologies with CMOS transistors, and in this fashion, we can use the memory element and sew really into the fabric of the computing system memory so we can finally find a way to distribute it, as we'd see, for example, in the nervous system of the fruit fly, Drosophila. So, in conclusion, what I wanted to say with my 3 minutes was look, there is much more to intelligence than just learning. We should look towards the nervous system of animals, in particular insects, because they are smaller and simpler, and see how we can transfer these principles, how they solve problems, to a new class of ultra-low power, massively parallelized and robust computing systems that have the potential to completely change the way artificially intelligent systems can interact with our lives. Thank you.
Thank you. Thank you very much, Thomas. Now I'd like you to welcome our third presenter, Nicolas.
So, is it working or not working? Working?
Working.
Working. Perfect. So, hi everyone. Machine learning is everywhere these days. We use it for a wide range of applications, as we've seen today, from playing chess and Go, image recognition, natural language processing, or data science. And as it often happens, new algorithms mean new machine, new hardware that we hope will deal more efficiently with these approaches. I'm here to convince you that although machine learning can be seen as a way to get your computer to figure out something automatically, figuring out the best way to use modern architecture to run a machine learning algorithm is far from being automatic. So let me introduce myself now. My name is Nicolas. I'm a brand new PhD student. I've started only 2 months ago, so I'm still trying to figure out what I'm doing here right now. But, however, I was an engineer before starting my PhD. And I worked on mapping a deep learning neural network on a very clever architecture that happens to be designed just a few kilometers away. It is a distributed architecture, which means that you have several computation nodes that must communicate explicitly by sending messages to each other when needed. As you could expect, you would like to have as little communication as possible, but also you would like to use all available nodes, then the best splitting of the world is not obvious at all. Imagine you have this image. So, and yeah, it's not the right one. The previous one, please. Yeah, this image. And you want to know if there is a butterfly in it. Imagine you have two computation nodes. You want each node to look into a part of the image. So, which way is the best way to split the image? Is it like this? Or like this? Or even like this? Well, you could think that all these ways are equivalent. The problem is that the process of finding a butterfly is not as I just told you. In practice, you have some pre-processing. Some part of the network would look for certain shapes, while other parts would look at the color in parallel. And then you could recombine the information you get on the color and the information you get on the shape. But of course, you first have to retrieve information on both shape and color before you can recombine them. As a consequence, there are many ways to split the work across the nodes, which can lead to very different results in terms of efficiency. In the team I was working with as an engineer, we had a reasonable default way of handling the splitting, and we made the choice by hand when the default was not satisfying enough. And as a PhD student, I am concerned with automating this process. We are striving to find algorithms that find the best possible splitting without any human intervention. And as the space of possibilities is enormous, it is possible, but it seems like a good fit for a machine learning solution, actually. So we will use machine learning for machine learning. So this is a bit of speculation, but you never know, and we hope. Thank you for listening, and have a good night, I guess.
Thank you very much. Thank you, Nicolas. And now our last presenter, Maha. Please give her a warm round of applause.
Hello. Today I will tell you about Jack. Jack is a very good memory designer. He decided to open his startup. The startup is growing, and it is difficult to Jack to manage all the work alone. So he decided to hire new employees. Jack and the employees now are working together, and the productivity is going better. However, new problem appears. The employees spend a lot of time to achieve the offices from their home because of the traffic jam between home and the offices. So to solve this problem, Jack authorizes the teleworking. Now the employees can work safely at home while enjoying good weather on their balconies. To link this story with my research field, assuming that the memory, the home is the memory, the employees are the data, the offices are the processor, and working represent computation. When Jack was working alone, it represents conventional system with single core processor and single memory, where the computation was not performed enough. When Jack decided to hire new employees, it represents the integration of parallel computation with systems such as GPUs or multi-cores. Today, we face a new problem, the memory wall. It is like a virtual traffic jam, but not with cars, with the data that spend a lot of time to reach the processing unit. The solution is adapt computation in the memory. It is like allowing your data to telework. This new computing paradigm, known as in-memory computing, consists in bringing the processing unit as close as possible to the memory or directly inside the memory. As a research engineer in CEA-Leti, I helped developing a new in-memory computing architecture based on volatile memory. So this system permits to perform logic and arithmetic operation inside the memory without bringing the data outside. My in-memory computing system highlights parallel computation on data, on vectors of data that are stored in the memory row. So I collaborate with memory designers and software engineering in order to think on the conception of the whole system flow design, starting from the silicon circuit design, going then to the system architecture, and third on the software development. I developed a new software emulation platform that is based on a high-level tool chain that permits to implement and evaluate applications from different domains, such as image processing, cryptography, or AI. I showed that my in-memory computing system permits to speed up the execution time up to 50 times and to reduce energy up to 13 times. Today, the in-memory computing technology permits, it is trained in the computing system. And in the future, I believe that it can have its place in our future smart devices. Thank you.
Thank you very much. Thank you very much, Maha. And let's applaud the 4 young scientists one more time. So, do you like surprises? Do you like surprises? Yes. I have 2 for you. First of all, a coffee break right now until 5:15, so 25 minutes. The second, a big, big surprise to have an artistic moment here with a special artist coming in from Barcelona. Don't miss it. All good? See you at 5:15.